Thank you. I'm seeing some more participation up there. So yeah, when different atoms bond together, this is called what? And it is called a compound. Yes. I'm seeing some people putting it up in the chat box now. Yeah, it is a compound. It's not an element. We talked about an element. An element is strictly like gold is only gold, and even if it's the smallest bit, it's only going to be gold. Matter is obviously what we're made up of. Okay, that's we're all made up of the same stuff. Okay, so that is matter. And then finally, protons. Well, that has to do with, the nucleus, inside the nucleus of, and so, of an atom. So again, compound is what the correct answer. Thank you. So, all right, here we go. What is the main characteristic you want of a best friend? Well, I already have one, but I'd like to say patience. That's a good characteristic. I think that's an excellent Malin characteristic. Anything up in the chat box? Let us know what a good characteristic of a good friend is. Again, we come across many people in our lives, but only a few can be really our best friend, because obviously they're those people that are very, very special to us. I like that, Gabriel. Loving, actually, loyalty, truth. Yeah, all of these are great characteristics. And I know all of you will live up to those characteristics with your friends. So just kind of be aware of that. We have friends that can come and go, but it's those true friends that live up to those characteristics of loving, understanding, acceptance, truth, loyalty, patience are the ones that will stick by us through thick or thin. Alrighty, so let's go ahead and keep on going. Remember, our Class Connect sessions are recorded and distributed for learning purposes. Please do not put any personal information of yours or others into the chat box for your protection, the protection of others. Make sure you're participating. It is extremely vital, and make sure that you're respectful and school appropriate at all times. Alrighty, let's go ahead and take a look at our attendance. Our attendance has been popping up into the chat box as we speak. I see it popping up there as I'm talking right here. Nice job, Mrs. Larkin. She's always on it. Again, we have the first 15 minutes of class to get your attendance in. After that, you do technically have until midnight tonight to get your attendance in. So if you want to do it a little bit later, that's okay. Make sure you copy that word down. Make sure you spell it correctly, but you have technically until midnight tonight to get it done. But you only have 15 minutes here in class. If you're late, just leave it blank. If you have to leave early, just leave it blank. You at least get half credit for what the portion that you are here for. With that being said, make sure that you go ahead and get your attendance in while I go through the schedule for today. No, we have not opened up the new project yet. That's coming soon. So our schedule, Mrs. Larkin, you need me to continue on, right? We're good, right? Right, excellent. So our schedule today is day 23 of 60. We're on Friday, January 8th. And so we're going to talk about chemical formulas. We are welcoming ourselves into Unit 3. So Unit 3 slides. We're going to talk about, don't worry, you don't have them yet. I'm not going to ask you to open them up yet because you don't have them. So just don't worry. So we're going to be starting our Unit 3 project, bonds project today. Okay. So with that, I'm going to go ahead and hand it over.
Perfect. Okay, so this is a reminder that yesterday your Unit 2 project was due. You do have a bit of a grace period, though. We're not going to zero it out till Monday, so if you need to work on it over the weekend, that's totally fine, too. You can still submit it even after we enter the zeros, but obviously your grade will be low until you turn it in to replace that zero. And we don't want you to turn it in too late, because then you're going to be really overwhelmed at the end of the trimester, which we don't want for you. We try to work on the projects every single day and make it really spread out. That way it's not overwhelming, but that means that you got to meet us halfway and be doing that work as well. They're also worth 85% of your grades, so you can't pass without them, so make sure you're doing them. And they're also graded on a 50 to 100% scale, which means as long as you give us a valid attempt, that means nothing is left blank, and that means that it's clear that you watched the recording and you didn't just fill in random nonsense words or nonsense numbers, then the lowest grade you could possibly get on a slide is a 50%. This is really good for you because that means you can only go up, right? So that means it's really easy to do well as long as you try your best, as long as you use the recordings. So that should be encouraging to you. We don't want to punish you for not knowing something. We want to encourage you for the stuff that you do know and then work with you on the stuff that you still need to practice. That's our intention here. That being said, we are starting our newest project. This project is actually a pretty short and sweet project. I know that it looks like there's a lot of slides, but I promise you it's going to go by really fast because each slide really only has one thing to do for the notes, and there are only 7 project-specific slides. So there's a story that you will talk about and analyze for an ionic bond, one for a covalent bond, polar, and one for a nonpolar covalent bond, and then your reflection. So the project part is super easy. This is a great way to make sure that your project grade is doing really well as a great way to make sure that you're actually learning this stuff really well. Okay, I know, so close to graduation. That's exciting for those of you that graduate after Try 2. So today we're going to talk about chemical formulas, and then we will be working through 5 different bonds. You will have 3 work days as well. The project will be due on Thursday, January 21st, so about a week and a half from now. So this is great because this gives you lots of time to make sure and perfect your project and make sure that it looks awesome. Again, one of the easier projects, so let's really knock it out of the park for this project. So let's go ahead and talk about our objectives.
Today we're going to talk about using chemical formulas to indicate the composition of a compound, and we're going to demonstrate that again through slides 2 through 5. Don't panic, you have not received your slides yet. So for those of you who are like, well, I haven't read, we're getting there. We're getting there. So let's go ahead and talk about that.
All right, so what we need you to do is, just like always, everything is always in your grades tab. That is something that you hear from us all the time, and if you don't know that yet, you're going to make me cry. All right, so go to your grades tab, either Larkin's or Sepulveda's, whoever class you are in. Scroll down, find the Unit 3 materials, Unit 3. And there's a Google version. If you want to use that, make sure you're logged into Google first, click on it, and then make a copy. Or if you want to use PowerPoint, you can download the PowerPoint version. Alternatively, if you want to take screenshots, photos, or notes for today and download them later, that's fine, but just make sure that all of that stuff actually does get into your template. Okay, yeah. I do want to show you a picture of what that looks like, so let me go ahead and pop that up on the board. So if you scroll down in your grades tab, you will see Woody and Jesse right here from Toy Story bonding. Woody somewhat reluctantly. But this right here is going to be our bonding, our friendship project. So Unit 3 friendship template is right below here. So again, there's a Google version and the PowerPoint version. Please raise your hand, everybody. Again, we will be checking in with people up to 3 times, and then we'll go ahead and, if need be, we'll log you out if we feel like you're not responding. Please raise your hand once you have your template open and ready to go. You have 30 seconds. Go, go, go. Stephen, that is fine. You can take pictures or write down answers. So still works. Raise your hand if you're ready to take pictures or write down answers. Shelbs, try the other link. Are you in your grade? Is the grades tab not opening or the actual template's not opening? If you're trying to use Google, make sure you're logged into Google. Otherwise, take pictures for now and we can troubleshoot later. You can text me or email me what's going on. Gotcha, Shelbs. Yeah, if anyone else is having issues, let us know, because if it's a widespread problem, then we need to troubleshoot it. All right, I am waiting on, let's see here, Gabriel, Ryan, Eric, Timothy, Christopher, Kale, Taylor, Moses, Patrick, Stephen. Shelbs, if you're good, raise your hand for the pictures. Stephen, if you're good to write down or take pictures, raise your hand. Adriana, John, Paul, Monique, Ignacio, and Tayan. Please raise your hands. Please raise your hands. Mrs. Sepulveda, your mic's on, just so you know. All right, you got it. Perfect. Stephen, thank you. Oh, yeah. Just give me smileys in the chat box. I know. Yes, I know phones don't work as easily. All right, I'm going to take a quick screenshot. All right, and we're going to be checking in here. Mrs. Sepulveda, are you good to do that, or do you want me to? What? Sorry, I couldn't see. Did you say you're good? Okay, perfect. All right, let's go ahead and keep on moving, everybody. So I'm going to go back to my periodic table. Again, you get 3 chances, and then we'll go ahead and log you out if necessary. All right, so let's go ahead and move on here. What I want to know in the chat box, let's start off with the brainstorm. What are some school-appropriate abbreviations that you use when texting or online? So, for example, BRB stands for Be Right Back. What are some other ones that we can think of? What are they? What do they mean? Tell me in the chat box. Go, go, go. I'll go ahead and write them up on the board for us. Yes, we have LOL, which means laugh out loud. AFK, away from computer. IDK, I don't know. XD, right, which is like a like, I don't know, how would you explain that? What kind of smiley would you explain that as? What other ones can we think of? We want abbreviations. So emojis are not exactly abbreviations. So what are shortened ways in which we text each other? Shortened ways in which we text each other. Yeah, TTYL, talk to you later. IDK, maybe IDC is also one. Yeah, right, Ignacio. What you doing? Exactly. OMG, oh my goodness, what else? What else can we think of? Tell me in the chat. Any others? My other classes came up with like 20, so I know we can do better. Yes, IK, I know. Yes. TBH, to be honest. NP, no problem. Look, I know so much text speak, guys. Any other ones we can think of? Oh yeah, BFF, best friends forever. TY, thank you. NGL, not gonna lie. Excellent. All right, so these look good. Yeah, thank you. I think one I often use for, yeah, TY often for thank you. THX for thanks. ILY for I love you. Perfect. All right. I think that's good for now. Interesting little history lesson here. When cell phones first came out, they were not touch phones. They weren't these phones. They also were not flip phones. One of my classes was like, right, there were flip phones. I was like, no, no. Instead, when cell phones that were text capable first came out, they were these brick phones. We called them brick phones. I had one of these when I was like 14 years old. And on these brick phones, if you wanted to get to a letter while texting, you had to press the number until you got to that letter. So if you had the number 2 and ABC, because they only had the number pad, again, no touch screens, you had to press the number 2 3 times to get to the letter C. And if you missed it, you had to go back and try again. Yes, it was so much work, Malin. It was very frustrating. So that is part of the reason that text speak kind of blew up, was because texting was really frustrating originally. It took forever to get a message out. So it was a lot easier to use these shortened words because that allowed us to get messages to each other much more quickly, as well as our text messages generally had limits on how many characters you could have. So it was a lot like Twitter, where you could only have like 100 characters, and so you couldn't really text that much. So interesting history lesson there, recent history lesson. And then the reason we're talking about abbreviations is because that is related to today's lesson, where we're going to talk about chemical formulas, which are abbreviations. So a chemical formula is used to abbreviate which elements are in a compound. Let's take a look at H2O. H stands for what? Tell me in the chat, everybody. H stands for what? Excellent. Ignacio knows what H stands for. Think about the periodic table of elements. Thank you, Stephen. Yes, H is the abbreviation for hydrogen. What about O? H2O. Again, what does the O stand for? That was your element. Awesome, Ignacio. There you go. Good connection. Yes, O stands for oxygen. Great. So we automatically know from this chemical formula that there must be hydrogen and oxygen in H2O, which we know is water. Okay. Now, that being said, there's another really important part, and that is the numbers. So there are what are called subscripts. Sub meaning below. So like a submarine goes below water. So these subscripts are going to be small numbers, and they're going to be low down. All right, Mrs. Sepulveda is going to send out the attendance one more time. Make sure you get that now, or forever hold your peace, and then we are going to erase the chat in a minute, okay? Awesome, I'm glad you got them open, shelves. Now, those subscripts tell you how many atoms there are of each element, and the subscript that they are applied to are for the element that it's right after. Okay, so this 2 is actually attached directly to this H. Smiley faces emojis if that makes sense. This 2 is directly attached to this H. The number that comes after, that's the element it's attached to. Okay, so what that means here is that there are 2 hydrogens in H2O, which we already knew. All of you walked into class knowing what H2O was, knowing there are 2 hydrogens in water. Pretty much all of you. All right, now oxygen, on the other hand, take a look here, has no subscript. Now, this does not mean 0, because if it meant 0, then why would we write oxygen? That would be dumb. All right, so we're not going to write oxygen if there's no oxygen in there. Instead, a blank subscript actually means 1. And a good way to remember this is that, for example, anything times 1 is still itself. So 3 times 1 is still equal to 3, and 2 times 1 is still equal to 2. And in the same way, oxygen times 1 is still oxygen. Thumbs up, smileys if you understand. Oxygen times 1 is still oxygen. All right, perfect. So again, blank subscripts don't mean 0. They actually mean 1. Blank subscripts mean 1. Excellent. This is going to be your next slide, your second slide. Fill in that blank right there, and Mrs. Floda is going to debrief that for us. Here we go.
Okay, which elements are in a compound? So make sure that you get the word formula right where it says the highlighted, where it says type here. All you need to do is write formula. I'll go ahead and type that in. I'm going to change my color. Although this, there. Look at Mrs. Larkin. She's on it. There we go. Formula. So remember, the subscripts are the small little low numbers directly after each element. That's going to tell us how many of that element is before that. So for H2, it's going to tell me how many hydrogens I'm going to have. 2 hydrogens. Okay. There is no subscript after that element. Then there is that element. Then there is only 1 atom for that element. Okay, so there's only 1 oxygen. All right, everybody, I'm going to go ahead and just give you about 20 seconds to do this. It's really easy, the word formula. 20 seconds up on the clock. Go, go, go. Do that after you finished. Yo. All right, let's go ahead and check in with a few people. Again, a lot of people I need to get it in. So Ryan, make sure you put your hand up. Tim, hand up. Christopher, please put your hand up. Thank you so much. I'm seeing people's hands going up. Perfect. Ame, Gabriel, hand up. Christopher. Taylor, Moses, Stephen. John Paul, Monique, Adriana, go ahead and make sure your hand goes up. Thank you, Ryan. All right, no problems. Thank you, Stephen, for reminding me. All right, last call. Ame. Gabriel. I think, Gabriel, you already talked to me in the, there we go. Thank you. Gabriel, once you put your hand up, leave it up there, my friend. Just leave it up there, okay? And Ryan, if you can get your hand up, Ryan. I know you talked to me in the chat box. Christopher. Taylor. Moses. John Paul. Monique, and Adriana. Okay, let me just grab a screenshot of a few people. With a few more people.
All right, so let's go ahead and talk a little bit about chemical formulas. So remember some review from a previous unit that compounds are different from their elements. They have different properties. So for example, sodium chloride, you can see its formula right here. Na stands for sodium, Cl stands for chlorine, and that Na has no subscript, so that actually counts as 1, and Cl also has no subscript, so that actually also counts as 1. So let's go ahead and talk about these elements separately. So sodium, Na, is actually explosive in water. If you add enough of this sodium metal to water, it will explode, it will break glass. It is pretty fun, but probably not something that you want to eat. Now, chlorine, on the other hand, is a non-metal. It is a gas, it is a yellow gas, and is actually also a poisonous gas. So again, not something that you want to eat. However, when they react and bond together, you create sodium chloride, and sodium chloride is just what? Take a look at your context clues up on the whiteboard. What is sodium chloride in the chat box? I have one answer. We should know what sodium chloride is. There we go. Yes, it's salt, exactly. So sodium chloride is just salt, all right? And salt, is it explosive or poisonous? Tell me in the chat box. Is salt explosive or poisonous, yes or no? No, exactly. So once it bonds, it begins to act very, very differently. All right, this is going to be your first fill in the blank for slide number 3, I believe.
Sodium chloride is harmless and it is table salt. We use it every day, hopefully. So if you don't, awesome, low sodium, but go ahead and put salt right there in the highlighted area, salts. Salt is only a 3-letter word, so it's pretty easy. We know that word. So 20 seconds up on the clock. Go. Hurry. Remember, if we don't hear from you, there's a lot of people that I have not heard from. Yes, Gabriel, it's 4 letters. Easy. Easy peasy, lemon squeezy. It's a long day. Long day until the beginning. So just checking in with a few people here. May, Ryan, I think you raise your hand when you get that. Ryan, Moses, last call, Moses, last call. I have not heard from you in the past 2 times. Moses. Alrighty, thank you. Much, Stephen, if you are, excellent. John Paul, Monique, John Paul, Monique, Gabriel, I've heard from you in the chat box. Ryan. Stephen, I know you're in the, and John Paul and Monique. John Paul, Monique, you were my last 2. John Paul, Monique. All right, thank you so much.
All right, so let's go ahead and talk about another example here. So compounds, again, have different properties from their elements. Oh, no. We can go back to it later, Derek. It'll also be in the recording when it's uploaded around 1 to 2 p.m. So don't stress about it. You'll be able to access that. All right, awesome. Let's go ahead and take a look here. So H2O is made from hydrogen and hydrogen and oxygen by themselves as individual elements are flammable gases. Think about how a candle flame needs oxygen. So what that means is that if you cover it up with something, it will be deprived of oxygen and it will literally suffocate and it will go out. Hydrogen, on the other hand, is also flammable. Remember, we talked about the Hindenburg disaster and how the Hindenburg disaster was an airship that we filled with hydrogen. And when it crashed, it had the double disaster of not only crashing, but it also caught on fire because of its flammability. So nowadays, instead of hydrogen, we use helium, which is another gas that is also pretty good at floating, but it's a non-flammable gas. But that being said, when hydrogen and oxygen react, they actually form water, and water is not flammable. It's also not a gas. Tell me in the chat box, what state of matter is water at room temperature? Yes, exactly. Yes, it is a liquid. So it is not a gas anymore. It is now a liquid. All right, so again, just taking home this point that they act differently. They act differently once they are bonded. Another interesting one is that hydrogen and oxygen can actually also bond as H2O2, which is hydrogen peroxide. And tell me in the chat box, what is hydrogen peroxide used for? You might find it in brown bottles in your bathroom. What is hydrogen peroxide used for? You might find it in brown bottles in your bathroom. Yeah, it can be used for cleaning. Specifically, a lot of us use it for cleaning cuts. It's very painful. It's an antiseptic. It helps to get rid of bacteria in your wounds, but it's also very painful. It's also not something that you want to drink. So it's very different from water just because it has an extra oxygen bonded. So again, when we bond stuff, the characteristics become wildly different. All right, I'm going to go ahead and show you a video of this in action. So let's go ahead and take a look at this. I'm going to make this bigger. And you're going to go ahead and tell me in the chat box what you observe while you watch this. I'm going to screen share this. And here we go.
When the 2 gases are mixed, a spark will cause them to react. The atoms explosively combine as a pair of electrons become shared between each oxygen and 2 hydrogen atoms. A closer inspection of the inside of the container shows water vapor condensed on the cool container walls.
All right, tell me in the chat box, what did you observe?
As a
particularly,
pair of electrons become shared between...
This part is lots of fun. Tell me in the chat box, what did you observe? Yes, exactly. It went boom. It was explosive. It was very colorful. It's very pretty. Again, these are gases right here. You can actually see the gases filled up right here. They did make different colored flames. A lot of different gases as well as different metals will make different colored flames when they're lit on fire. But yeah, so they reacted here. You can see they're gaseous. And then by the end, you can see that on the outside of the container, it had liquid water. It's no longer a gas. It's now a liquid. And this water was no longer flammable. It's not like it's not like it kept on burning while it was in the process here. Okay, so let's go ahead and jump back over here. I'm going to stop our screen sharing and jump in here. Yeah, it's probably metals. Metals usually change colors. All right, here we go. This is going to be your next slide. Here we go.
Going through each of these slides. So water, H2O, is a non-flammable liquid. So just like we talked about before, let me change my color. It is going to be the word liquid. So go ahead and lock in your answers. Again, I do need to see your hands raised. Make sure once you have your hands raised, or once you lock into your answers, you have your hand raised. So raise your hand. I'm going to give you about 20 seconds. Go, go, go. Keep calling the same people. Again, this will be our third time, so I will just log you out, call your name once, log you out. So just checking in with a few people. People are moving around. Ryan, Kale. Stephen, I think you're in the, I know you're working. Perfect. Thank you, Stephen. I see your happy face. All right. So Gabriel, I know I see you up there. Ryan. Stephen, no worries. Okay, cool. No worries, Taylor. Thank you for letting us know. So Adriana, Alberto, Destin, Ignacio, Monique. Some of you have already, or everyone's kind of moving on me, so give me just a quick second here. Alexis, Kamari, John Paul, Monique, Destin, Adriana. Last call, Alexis, Kamari, John Paul, Monique, Destin, Adriana. Alrighty, thank you so much.
All right, so let's go ahead and actually begin to apply some of this here. So what we're going to do is we're going to take a look at some chemical formulas, and we're going to go ahead and break them down and figure out what is in each chemical. So we're going to take a look at sulfur dioxide, which is a gas that is toxic. So let's go ahead and take a look at this. What we're going to do is we're going to write it out so that each element is by itself, and if it has a number after it, we're going to have that number stuck to that element. So let's go ahead and take a look here. We have sulfur S, which has no number, so I'll just leave it by itself. It has no number after it. And O2, which has an 2 stuck to it after it. All right, so let's go ahead and break this down. So S stands for sulfur, and taking a look here, there is a blank subscript, and again, blanks don't mean 0, because if they meant 0, we would just get rid of it. Blanks actually mean what number? Tell me in the chat box, a blank subscript actually means what? Think about sulfur times what will still be sulfur. Excellent, I see Malin, I see Shelby in the chat box. A blank subscript means what? It does not mean 0. 0, we wouldn't even have the letter there. Yeah, it just means 1. Exactly. So we're going to do 3 practices together. So you need to make sure that you're really understanding this, because the next slide you will need to be able to do on your own. So just a heads up. So taking a look here, then how many sulfurs are in sulfur dioxide? Based on this blank subscript, we know there are how many sulfurs in sulfur dioxide. Let's make sure we make that connection. Tell me in the chat box. How many sulfurs? How many sulfurs? Perfect. I see Ryan, Daniel, Stephen, Miles, Camilla. Yeah, exactly. So there's 1 sulfur in sulfur dioxide. Perfect. What about oxygen? This one should be a little bit easier. Take a look at its subscript that it has after it. All right, and tell me how many oxygens are in sulfur dioxide. Thank you, Ryan, on top of it. Annabelle, Malin, Daniel, I see you. Yeah, the last one's a little bit rougher. Exactly. I see Camilla. Yeah, this one is going to be 2. So 1 sulfur, 2 oxygens is the answer for the first question on slide 4. Please take 20 seconds to answer that, and then raise your hand. Sorry, I'm going to lower these current hands. Raise your hand when you're ready to move on. Go, go, go. All right, we are waiting on Lydia, Adriana, DJ, Tayan, Ignacio, Jaden, Monique, John Paul, Alexis, Stephen. In the chat, I see you. Never mind, Stephen, you're good. Let's see here. Gabriel, Ryan, Michael, Eric, Timothy, Kale. Some of you, this is your 3rd chance to respond. Remember, you need to respond within three attempts to contact you. We need to know that you are here. We need to know that you are participating, or that if you're having tech issues or whatnot, you need to be communicating that with us too. Okay, you can't just sit here and expect to get attendance. You got to make sure you're participating. Again, waiting on raised hands. Gabe, keep your hand up. Same thing, Ryan. If you raise your hand, keep it up. Eric, Timothy, Stephen. I know, Ryan. I know you're here. Do you know where the raise your hand button is? I think you found it. Okay, perfect. Yeah, just leave it up. There you go. Thank you. All right, Alexis, John, Monique, DJ, Adriana. Okay, no worries, Bryce. Thank you. Perfect. All right, Mrs. Sepulveda is going to check in with a couple of you that have not yet responded. All right, and let's go ahead and take a look at this next problem. Did you want to do this one, Mrs. Pulvida, or are you still checking in with people?
All right, so slide number 4 is going to be a complete on your own. Remember, let's do this together, the first one, and then you're going to look at, then
No,
you're going
this
to,
is a together one, sorry.
oh,
Slide
is it a together
5
one?
they'll be doing on their own.
Okay, slide 4. Here we go. Let's do this together. Let's do this together. So looking at the problem here, we have C2H4. So we have C, and then we have 2, and then we have H and 4. Okay, separate it, bring it out. So looking at the 2 right here, how many carbons do we have? How many carbons do we have here in this particular compound? Yeah, good, good, good. Excellent. So then we go ahead and put 2 carbons here. Looking at this second one, how many hydrogens do I have in this compound? How many hydrogens do I have? Nice, Ignacio. Nice, Alberto, Camila. Good, excellent. Yeah, I have 4 hydrogens. I have 4 hydrogens here in this particular compound. So again, how many atoms do we have in each of this element of ethylene? It is going to be 2 carbons and 4 hydrogens. Go ahead and lock in your answers. Again, we're only going to give you about 20 seconds to do this. It should be really, really easy. Raise your hand when you are finished. Raise your hand when you're finished. Go, go, go. Excellent. Let's go ahead and check in with a few people. Again, this will be my last call. So then I will start erasing people that have not raised their hand in the last 3 calls. And I've checked in with a bunch of you and no responses though. Not good. Ame, go ahead and raise your hand. Thank you. Gabriel, Ryan. Bryce, I know Bryce, you stepped away for a second. Eric, Tim, Derek, Kale, Patrick, Stephen, let's see, I think I see you in the chat box. There you go. Hi, Stephen. There you go. And Kamari, John Paul, Monique, Jaden, and Destin, and Adriana. So still looking for those. Thank you. Thank you so much. Eric, Tim, Kale, John Paul, Monique, Adriana. Last call, Adriana, Monique.
All right, so let's go ahead and do this last example together. This one is actually a little bit more complicated because you'll notice that some elements actually appear more than once. So this is acetic acid. Acetic acid is found in vinegar. We're going to go ahead and separate it by letter, and if it has a number after it, we'll keep that number after it. So we have C by itself, we have H3, we have C by itself, O, and H. Okay, so what I want you to take a look at with this right here is, first of all of these ones that do not have subscripts, again, those do not count as 0. What do those count as? Tell me in the chat box. All of these that don't have subscripts, blank subscripts actually means what? Does not mean 0, it means perfect. Again, this is our last one that we're going to practice together. Yes, it means 1. So each of these are actually followed by 1s. All right, so let's go ahead, and what we need to do is we need to add up anytime we see, for example, starting off with carbon. So we have a C1 and a C1, and what is 1 plus 1? Tell me in the chat box. How many carbons do we have in total? 1 plus 1 should give me? Perfect, this should give me 2 carbons. Excellent. Go ahead and in the chat box, without any extra help, go ahead and try the hydrogens. Find all of the hydrogens, add them together, and tell me how many hydrogens do you see? Looking good, looking good. I see some answers popping up. Excellent. Yes, you should have noticed that there's an H3 right here and an H1 right here, and 3 plus 1 gives me 4 hydrogens. Last but not least, try that oxygen on your own. Find all of the oxygens. Again, blank subscripts stand for 1. So if it's a 1, add that 1. Perfect. Yes, O1, 1 plus 1 should give me 2 oxygens. Great job on that. I'm going to go ahead and lower these current hands, and please raise your hand once you have slide number 4 completely filled out. We should be finishing it up. 20 seconds. The next question you need to be able to do on your own. Here we go. All right, I am waiting on Ame, Gabriel. Okay, Gabe, you're good. Never mind. Bryce, Eric. And let's see here. Timothy, Alan, Kale. Taylor, Shelby, Alexis, and Jaden. Thank you. Just waiting on Bryce, Timothy, Let's see here, shelves. Yeah, there are parts of chemistry that are definitely easier. I wouldn't say it's all easy though. Looking good. All right, just a few people in there, so I'm sure Mrs. Sepulveda will be checking in if need be. Thank you, Bryce. Awesome. All right, so this last question you need to be able to do on your own. I am going to go ahead and help break down the hardest one for you, which I think is this last one, phenol, C6H5OH. So let's go ahead and begin to break this one down. So we have a C6, an H5, an O by itself, and an H by itself. So taking a look here, these ones without subscripts, the blank subscripts actually stand for what? Blank subscripts stand for what? It's not an O, it's not a 0. Okay, otherwise we wouldn't include them. So blank subscripts mean what? Thank you, Angelo. Thank you, Camila. Thank you, Daniel. Yeah, exactly. They mean 1. So this actually stands for O1. This stands for H1. So we have 6 carbons. How many hydrogens do we have? 5 plus 1 equals what? 5 plus 1 equals what? Okay, awesome, Stephen. Glad you did that one already. Perfect. Yeah, so this equals 6, right? So we have 6 carbons, 6 hydrogens, and then 1 oxygen. So that would help us match up with this one right here. Remember that this is a drag and drop, so you can just click the edges of the yellow boxes, drag and drop them over to where they belong. You don't have to draw lines. You don't have to type it out. Everything's already there set up for you. You have 45 seconds to raise your hand to let me know that you are ready for this one. Go, go, go. Take a picture if you need to. We're almost there, Derek. 30 seconds, everyone. All right, waiting on a raised hand from Christopher, DJ, Taya, and Jaden, Alexis. I know Steven's good in the chat. Kale, Timothy, Eric. Kale, Timothy, Eric. Again, we're saying a few of these names over and over again, so you're not going to get attendance if you're not responding. So please make sure you're responding. And then Ame, Gabriel, awesome, I see you. Looking good. All right, perfect. All right, looks like we got most of our people. I'll let Mrs. Pulveda check in with anyone that she needs to. Yep, Gabe and Ryan are working. Perfect. Okay. Looking good. Let's go ahead and keep on moving here. So just a quick summary for your project. Your project is all about friendship, specifically the bonds between a metal character, a non-metal character, and a few other characters that you'll be meeting in your story. All right, so what you need to do is you need to choose a metal and you need to choose a non-metal. There are 3 metals you can choose from and 6 non-metals that you can choose your character from. Once you choose your characters, you need to fill out their basic information from the periodic table. Now, you should already know how to do this. This is all from the last unit. So if you feel confident, then feel free to begin filling this out. If you're not yet that confident and you would like a little bit more guidance, I will be going over these project slides step by step in the Thursday recording. So don't panic. Again, if you're like, I feel like I should know this, but I don't remember it, Mrs. Larkin, don't feel bad about that. We will get some more practice on Thursday. So don't worry if you're not ready to do it yourself. But again, all of you have seen this before at some point. So you'll choose your metal element. You'll identify the number of protons based on its atomic number at the top of its square. And then you'll identify the number of total electrons when it's neutral, which should be equal to protons. Positives and negatives cancel out. Then you'll identify just the valence or outermost electrons, which is based on the group or column. Remember, group 1 has 1 valence, group 2 has 2 valences, and group 13 has 3 valences, 3 valence electrons, okay? And then how many would they need to lose to drop down to a full shell? So 1, 2, or 3. So again, stuff you should already be pretty familiar with. No, you need to choose the ones that are boxed, so you can't choose lithium. Lithium is not an option for this project, just FYI. So make sure you're choosing within the red box. All right, same thing with your non-metal. All right, so there are these 6 that you can choose from. So same thing, choose it, and then how many protons, how many electrons in a neutral atom should be equal. Just the valence electrons, that's based on groups, right? So group 15 has 5, group 16 has 6, and group 17 has 7. Okay, and then based on that, how many more valence electrons would it need to get to a full shell, which is, again, a perfect octet, which is 8. So that means if you're in group 15, you need 3 more. If you're in group 16, you have 6, you need 2 more. If you're in group 17, you have 7 valence electrons, you need 1 more to get to 8. Again, everything that we should be familiar with, make sure that you begin to fill these out. That way you know your characters for your storybook. All right, looking good. All right, let's go ahead and wrap up here.
At this point, we're going to go ahead and stop our recording. And we'll